Hello, everyone. How's everybody doing? I'm not doing too good. Just recovering from a cold. I'm still congested, but I guess I'll live. Thought I was gonna go extinct these past few days. I was in really bad shape. Anyways, the show must go on. So here I am. Um, I came back from the seventh Rational Physics Conference in Boras, Sweden. And I want to thank Martin, first of all, and his family. I think they did a good job. They had the beer they promised. I was surprised that Sweden has blue laws that you can only buy 3% beer at the store. If you want 6% beer, you got to go to the bar, but you can't take it with you. You can't take the bottle with you. You got to drink it there. Okay? But somehow he was able to get beer, 6% beer. So Martin did a great job, I think. Okay, and some good people. We had some good discussion, especially after the show, which is really, it's those workshops. Those are the ones that are very interesting because people, have questions, and and that's where you settle them. You try to find out, pick the other guy's brain and find out, if you can answer the questions you came for. So that's what it's about. And the next one, the eighth conference, we've had them where? We've had them in Scotland, we had them in Austria, Argentina, Mexico. We had them in quite a few places. And the next one is going to be in Lusaka, Zambia. It's going to be hosted by Mr. Shaun. Here, let me put this up here. And yeah, we're going to have it among lions, I guess. And the funny part here was that poor Shamu, he came up and he said, "Look, guys, I can offer maybe, perhaps, we could go to Lusaka." And he probably didn't. He wanted maybe to pull back his offer, but my wife beat him to the punch, and she told him, that was on her bucket list to do safaris. And I don't know, she's a very violent woman. She wants to kill lions and crocodiles and who knows what. And so poor Shamu, he couldn't withdraw the offer. It was too late. And so now we're stuck with Lusaka. And if everything goes okay, we're probably going to have it somewhere between January and February of next year, 2020. So if you're interested, in going down to Safari Country. Yeah, the piano guy. Yeah, Mark was saying. Yeah, if you're interested in if it's on your bucket list as well, like on my wife's, well, this is your chance. Let's go and get down there and let's have some fun. And there are several flights that go down there. KLM goes through Addis Ababa. It takes a connection with some African airline, the Ethiopian Airlines. I think Turkish Airlines flies. There's another one from the Emirates. So there's several ways to get down there, and let's have some fun. Let's do the conference among lions. Anyways, Martin talked about something interesting. He proposed a different atom, essentially, and his atom consists instead of one rope coming to the atom, he has two ropes coming to the atom. Okay, one of the strands from one rope, the other strand, another strand from one of the other ropes. They untangle here, and they tangle together. Okay, the loose strands, they form the electron shell. The mated rope, as he calls them, go to the center of the atom and out the other end. And so essentially the difference he's proposing is that the rays that I have in my atom that form the proton dandelion, he's got them with ropes instead of single threads. And it's a proposal that's got its advantages, I have a couple problems with it, and I also like a couple things about it. So it's something that's got to be looked at. And Monkey Mind, he's a guy who I think analyzed it to some degree. I'm probably going to pick his brain, find out, so that I don't have to reinvent the wheel again. Maybe Monkey Mind's already figured it out, how some of the pros and cons and that kind of thing. But I think it's worth considering. At first sight, I thought it was an interesting model. And, just like all models, you got to look at them, you got to study them and not reject them, right offhand. And what did I present? Well, I presented two things. I had two presentations. The first one had to do with the foundations of physics. What is physics about? And the second part, I did extinction. And yeah, there's a little more resistance there to accepting that theory. Uh, Usually people say, Bill's crazy. I'm crazy enough with a rope, but when I get to extinction, people say, well, he's lost it completely. And so on with the show. Let's see, I'm going to do a little revision of these two presentations if I have time for all of it. Let's go with the first one, Foundations of Physics. And the question I ask is, what is physics about? You hear a lot of stuff today about, black holes, dark matter, the Higgs boson, particle of mass. And a lot of people have doubts about it. A lot of people don't like that. And those are usually the people who seek out and find people like me. And what don't they like about it? Well, they find a lot of that irrational, counterintuitive. To their surprise, the establishment also finds it counterintuitive and irrational. In other words, they can't explain it. They have no explanation, no rational explanation they can put for you. And they confess this. Now, half the people out there are not aware of that. They think that everything's all right and that these guys have proven the theories and that the theories are alive and well. And even they say that, even though, if you look at these celebrities, people like Sean Carroll and Michio Kaku and Brian Greene and so on, and they'll tell you in your face they don't understand their own theory. It's like you're not listening if you haven't heard that. They're telling you that they don't understand their own theories. And when you tell that same person, look, Brian Greene says he doesn't understand his own theory, say, well, you're taking it out of context. Of course they understand the theory. How would we have computers if they didn't understand the theory? How would we have, GPS and so on? And so we got a problem first with that group of people who believe somehow that everything's okay out there. And the main reason for that are two. There's two reasons for it. One is that technology is working. And if it's working, it means that the theories can't be that far off. That's one argument. The other argument is the argument of authority. All these PhDs around the world, every university, they can't all be wrong. And those are the two arguments. That's it. They have no more argument other than that. Now, the other half of those listeners, they agree, yeah, there is no rational explanation. And those can be divided into a couple groups as well. There's one group that says humans will never understand because the intelligence of humans or the way the mind works of a human is not prepared, not capable of understanding how the universe works. Okay? So they're saying we're born, we don't have it in us. We have all this intelligence that Mother Nature gave us through evolution, or maybe even it was God with his magic wand, whatever. But the point is, we have all this intelligence, but that intelligence doesn't match the intelligence of the universe, so to speak, of how Mother Nature or Father Universe run their shops. And so it's like, you can't get to those people because they don't expect a rational answer. They say it's impossible. And so they have no problem in accepting the bogus explanations of quantum mechanics. So if quantum mechanics tells you that a particle can be at two places at once, I mean, that's about as irrational as it gets. And these people go, okay. What do you mean, okay? Well, yeah, we're not supposed to understand how the universe works, so What's wrong with that? That's the answer. And that's one group of people. The other group of people says, well, we're still investigating. Someday we'll understand. Okay, so we have all these people out there, and those are the people if you are a rational individual, those are the people you encounter out there. Those who think that everything is okay, that the quantum mechanics and general relativity perfectly explain, not describe, but explain mechanisms of how this universe works. There's the other half, and those numbers are just pulled out of the top of my head. The other half can be divided in two groups. Those who say, well, we'll never understand it because we can't understand it, and those that say that someday we will understand it. You just need to send the funds in. We're going to continue to do research. You just send the money and we'll do the job, okay? Generation after generation after generation. Someone will figure it out. And so that's what we have today. That's it. And so what does a rational person do? Well, he takes a step back, and at least what I did was erase the entire board completely. Completely. People say, no, leave poor Newton there. He was okay. They were doing fine until the 19th century. We were doing classical mechanics, and then we jumped into this nonsense of quantum mechanics and general relativity. Now, we got to erase the whole board, all of it. Newton included. We got a problem with Newton. I got a problem with Galileo. Got a problem with the entire 17th century because they changed the rules on us. The word physics, as far as I'm concerned, the word physics comes from Aristotle, from his book, the eponymous book known as Physics. He wrote the book Physics, and that's where we got the word. And Aristotle said something right off the bat, second book. He says, there's a difference between a mathematician and a physicist. Mathematician, he identified with geometry, numbers, angles, that sort of thing. That's their world. What does a physicist do? Causes. 17th century, well, we went to 2,000 years later, approximately. We got to the 17th century. And what happened? Well, these people, even before that, you get people like Roger Bacon. He was a priest, man of the church of the 13th century. He's already writing about, we need to really confirm things through experiment. And by the time you get to the 17th century, that's what they do. They're starting to do experiments. They describe whatever they do mathematically, and we take a left turn, a very sharp left turn for what we can call today the scientific method. Starts in essentially in a practical way, in a pragmatic way. It starts in the 17th century, and so yeah, they do math, they do measurement, they start observing this invisible world in more detail, light. They say that the mediator is the ether. Everybody believes in the ether. Everybody, both Newton and the wave guys, everybody thinks of the ether as a bunch of particles. The only difference between the wave guys is that they believe the ether is vibrating. These little balls, they're vibrating. And the Newtonian guys, he's going to triumph for the next maybe 200 years or so, probably less. They believe that, light travels as a ray, some kind of ray, always in straight lines. And so the issue was refraction. Why does that pencil bend when you put it in the water? What's happening there? And Newton says, look, the ray is being pulled towards the denser object. That's what's happening. You got more density over here, and that's bending the ray over. Okay? But it's not that they had a different idea of the ether. They all believed in particles. They all believed the ether was a bunch of particles. And it's just that some of them felt that it's a vibration, and Newton says, you can't get he was thinking really of a transverse wave in the middle of the ocean. He couldn't picture that, and he was right about that part. And then he was wrong about the other part, saying, well, it's a straight line, travels in straight lines, but the reason it bends like when it goes from air to water is because it goes into the denser medium. And he was thinking again a little bit about gravity. He says gravity should pull it inwards, and that's the idea he had. Higher density, the ray gets bent. Straight line, but you bend that ray over. And that lasted until at least the 19th century, classical mechanics. And then we got into the good stuff, and that was the 20th century where we started doing some quantum mechanics. Forgot about all classical mechanics. What does quantum mechanics means? It means irrational mechanics. That's exactly what it means. Quantum is a euphemism not for particle, not for packet. It's a euphemism for irrational. All explanations after that were irrational. Why were they irrational? Because they were using concepts as objects. They started, the words of mathematics somehow acquired materiality. They acquired bodies. Energy became a physical object. Mass became a physical object. Field became a physical object. And so now you ended up in this world in which you have the excitation of the field. What do you mean of the field? Field is a region. It's a bunch of values around an object. That's what a field is. It's a mathematical concept. So now the numbers were vibrating. What is energy? Well, it depends on if you're talking about ergs or joules. There's all these kinds of energy, and they're all concepts. Obviously, if you can put a number to it, it's a concept. It's a value. And now they say, well, we transferred this value. I transferred the value to you. You caught it. So what did you transfer? A number? A unit? So, or you push a mass. What do you mean you push it? You probably pushed an elephant, not a mass. You didn't push 6 tons, you pushed an elephant. That's what you pushed. One is physics, the other one is math. Well, we forgot about the objects, and all the concepts became objects. And the mathematicians saw that by saying, well, you know what I mean. And that's where we are today. Okay, so I had to take a step back, erase the entire board and say, look, let's start all over. Let's start all over. Let's find out what physics is about. And I go back to Aristotle. He may have had the wrong scientific method. Maybe he should have checked some of his reasoning, let alone, test with some experiment, like, the famous experiment of the 2 stones, heavy, light. If he would have done a simple experiment, he would have found out that they fall down at the same time. But like Galileo says in his book, you don't need to do an experiment. You don't need to measure anything. You can do it with armchair physics. You can stay back, and he showed how, through reasoning alone, how you can arrive at that conclusion. He states that in his book. So if you read his book, you'll find out Simplicio, who's the guy who's the dumb guy in his book, in Dialogues, he said, well, how about this and how about that? And Galileo does explain it to him. He says, you don't even need to do an experiment. But experiment just seeped in there, and mathematics seeped in there. And today, you can't get that away from anyone out there, especially the people from the electric universe. They say, oh, you need an experiment. No, you don't. Experiment is there to prove to you, to convert you. That's the only reason, for proof, for your evidence, your personal evidence, your personal God. The roses prove to you that God exists. That's proof to you. It's not proof to your neighbor. And so we don't do experiments in science or in physics. We explain them. We don't do them. We explain them. And what we can't do today is explain them. We do lots of experiments. Yeah, here's an experiment. Here's one of the breathtaking experiments I did at the conference. Here you have 2 magnets, a little magnet there in the center. Now, how's that for an experiment? 2 pieces of metal, right? And they stick to each other. No one on planet Earth in the last 400 years and even today can explain this in mathematics. And this is what we got to explain. We got to explain this. We got to explain this other major experiment, which I did also at the conference. Very, very expensive experiment, so I can only do it once. You let go of the pen, and it falls to the floor. So I did the experiment that you wanted me to do. So there, you have an experiment. You want me to do it again? I'll do it 100 times, 1,000,000 times. It always falls to the floor unless, maybe you got some magnets pulling on something out there, But otherwise, we know that it's going to fall to the floor. We've done the experiments. We've done the slit experiment. We've done polarization. What we have to do is explain them now. And we have to explain them in a rational manner. And that's where we failed 100%. That's the failure of quantum mechanics. That's the failure of general relativity. It's a failure of the electric universe and all these other people out there. Why is it a failure for these people? Because they are moving concepts. They're not moving objects. You got to start at the beginning. You got to know what an object is for the purposes of physics before you do any physics. You got to learn that on the first day of class. And none of the people of quantum mechanics, electric universe, or general relativity, none of these people ever took the first class in physics. You say, how can that be, Bill? Yeah, no one doesn't understand what the foundations of physics are. And that's what I talked about at the conference. So what are these foundations? Well, you start out with a principle, what I call the golden principle. You can't do physics without an object. Let me repeat that. You can't do physics without an object. You can't do it with concepts. You can't do it with intelligence. I just have intelligence in the universe. I'm going to move it around. I'm going to, massage it? I can't do anything with intelligence because intelligence is not a physical object. If you want to do physics, the first thing you need is an object in the universe. So if God removes all the matter from the universe, there's nothing going on until you put something in there. And we need to know the difference between something and nothing. What is something? That which has shape. Very simple. It took 10,000 years for that definition to surface. Not only the definition for it to surface, but also to recognize its importance, how important that definition is for the purposes of physics. The fact that we do need objects and that we need a definition for the word object. You can't begin to do physics without it. And I'm saying furthermore, not only do you need to understand what an object is, but you have to distinguish it from concepts, okay? And for all practical purposes, as a quick rule of thumb, right? Object, that which has shape. Concept, that which doesn't. Now that's straightforward. Look up every word in the dictionary. You can divide them in those two categories and none other. There are no more categories. There are only two categories. Either it has shape or it doesn't. Either God has shape and is an object, or God is a concept. God can be intelligence, God can be love, God can be information, whatever you want him to be. But then he's not an object. He's a concept. You're praying to a concept. Or God can be this guy with the magic wand out there who created the universe. Maybe he's a flaming bush as he appears to Moses. Okay, fine, then he's an object. So God can't be both. God is either an object or he's a concept. And that's where all religions die, including general relativity. Is space-time an object or is it a concept? Well, the mathematician would like to say, just like the Christian says for his God, he's both. Both. Oh, yeah, okay. Yeah, he's both. See, over here, when we deal with math, he's a concept, the space-time, right? And over here, when we have to explain how the Earth goes around the sun, well, the sun has to bend something physical, because otherwise the Earth would run away, just drift out of the solar system. So what wall is there preventing the Earth from flying away? Well, that's the wall of space-time. We bend space-time, physical object now, you know, and how we treat space-time as a physical object, and the Earth rolls around this little depression, gravity well. So, that's the problem. They turn it into both because they need both. Point, it's both a location and as well a dot. So they put a dot and they say point. The dot is a point? No, no, it's a location. Location of what? Of whatever's at that point. And it's a circular argument. Okay, and the electric universe, these people have even worse things because they borrowed all these concepts from quantum mechanics, primarily. And what are the concepts that the electric universe turns into objects? Well, they have several. Here I've synthesized them. Let's see if I can put them up here so that we can see what are non-objects for the purposes of physics. And here you have the first one. You have the vortex, famous from the electric universe. A lot of them subscribe to vortex. You have the famous Birkeland currents. Oh my God, they do everything with these Birkeland currents, which is essentially electricity, which you've got up there on the upper right. And then you have the almighty and famous plasma. Well, none of these are objects for the purposes of physics. And it takes 2 years to convince, a person from the electric universe that none of these qualify as standalone objects. And here is what they missed. Let's see if I can put this up here. The one on the left is known as a kangaroo. It's a photograph, picture, statue. As you can see, it's not moving. That's an object for the purposes of physics. The guy on the right, that's not a kangaroo. Yeah, I know he looks like a kangaroo, but he's not a kangaroo not because he doesn't look like one. He's not a kangaroo because he's moving. That's why he's not a kangaroo. That's a jumping kangaroo. And a jumping kangaroo is not an object for the purposes of physics. Okay? So if something is in motion, you can't say that the jumping kangaroo jumped. You can't say that in physics. And this is not an issue of semantics, no. This is an issue where you are putting something that is already in motion and you're saying you're going to put it in motion. That's the problem. And that's what all of these are. All of these are jumping kangaroos. They're all moving. Vortex is something in motion, whatever that something is. Birkeland current, current in general. It's something that's already in motion. So is electricity because electricity is current and current is electricity. Plasma, also something in motion. And it's very hard for someone who's been stuck with the religion of plasma, of electricity, to change that religion at the last minute and say, oh no, you're just doing semantics, you're trying to confuse me. It's like someone's deep in a hole. You're trying to pull them out. And the guy says, no, I'm okay down here. I'm safe down here. And so they have this false sense of intellectual security. They're down in a hole and they believe they understand, they know everything. And you can't, talk sense into them. Now, I've been there and done that, okay? I want to tell you, confession time, I got to do that myself. I was a communist for 20 years of my life. And for a little more than that, I was an atheist. And I got out of those two religions. I'm sure if you would have come when I was 20 years old, 25 years old, there's no way you would have convinced me against communism. Here I was, world government. Eventually, we're going to have this, this dictatorship of the proletariat, which is absolutely necessary to reach that world government. And then eventually, this world government will, cease to exist as well, and we have this world without a government. Not anarchy in the 19th century sense, but anarchy in a sense that you don't need someone to govern over you. Or like I usually say, you go to an island, with Trump or George Bush or one of these guys, you don't go to him and say, look, I need for you to rule over me because, I don't know how to behave. No, you don't need a government. But the issue is that we do have a government. And well, it took me a long time to get out of my ideas. And atheism, I thought I was quite rational, saying, look, atheism, there's no way you're going to prove to me that atheism is irrational. And yes, today I have to admit that it is irrational. It's irrational not because it means that God exists. No, it means that you got to put atheism, agnosticism, and theism, all three in the same boat. They're all religion, all three of them. What opposes them is science, the scientific method, the rational scientific method. And you say, how is that different? What are you going to introduce? I mean, God exists, God doesn't exist, maybe he exists. What other option is there? And this is the issue. And you got to understand the argument. Again, unless you understand the argument, you're never going to look at that guy in the mirror and tell him, I was wrong all these years. So you got to listen to the argument. The argument is, in science, we say, let us assume that God exists. God can only be a hypothesis, a proposal. I'm not going to theorize about God, about existence, any more than I'm going to theorize about the existence of a chair. The word exists only can be a proposal, an assumption. And the way we do it in science, we don't say, oh, God exists. Or we don't say, oh, I believe that God doesn't exist. Or I disbelieve in the existence of God. Or any way you want to twist it or turn it. It doesn't matter. The way we say it is, let us assume that God exists. Now I can proceed to explain my theory. My theory is that God has this magic wand and created the universe. Okay, do you believe it? Well, some people believe it, some people don't. Period. That's religion. Belief has to do with religion, opinion. In science, we're just interested in understanding what the guy has in his head and whether it's rational. And so we look at it objectively and say, okay, what is your theory? What's your proposal? And so the guy has to begin, let us assume God exists. Okay, let's concede the assumption for the sake of argument to understand the theory. And now we can follow his train of thought. And he says, okay, look, let us assume God exists. He's got a magic wand. He's got all these superpowers, and he created the universe. Okay, we're done. We understood the theory. Do we believe it? Do we don't believe it? That's a separate issue. We understand what the guy's proposing. Okay? And you say, well, how is that like, space-time? Well, the same thing. Let us assume that space-time exists. But now we have a problem, because in the case of God, I'm presenting him as a magician, as a human-like person. He's got a wand, he's got a brain. So we can all more or less relate to that. Say, okay, there's this big magician out there, right? Again, you can't introduce him as intelligence. You got to introduce him as a physical object. And space-time, what are you going to do? You're going to introduce him as a concept or an object? Well, if you introduce him as a concept, mathematical concept, that we're done. It's got nothing to do with physics. So the only way you can explain a physical mechanism is by saying, well, space-time is this ocean or this steel beam, whatever it is to you. Yeah, you're the guy who's giving the presentation. And so you say, well, we bend space-time, right? And the Earth rolls around the sun. Okay, so now we understand your theory, your proposal. Do we believe in it? Do we provide proof, evidence? We don't care about any of that. We just want to understand what your mechanism is for how the Earth doesn't fly out of the solar system. And that's what we're going to analyze. And you can't say, well, let me bring proof so that I can convince you that my theory is correct, right, perfect, true. No way. Right now, we're just going to look at the mechanism. We're going to say, well, what is this space-time? What is it made out of? How does it bend? There's going to be a lot of questions on this material thing that you call space-time. You can't switch back and say, well, I was only kidding. It was supposed to be an abstract concept, mathematical concept. You need to take math to understand what I'm talking about. No way. The Earth rolls around the sun. Something is blocking, you're claiming that something is blocking the escape of the Earth. Don't tell me I got to take math. I just want to look at the mechanism. What physical object prevents the Earth from flying out of the solar system? And in that sense, you find out that space-time is more irrational than God. God is, to some degree, you can accept. You say it's a rational proposal. The guy is saying there's Superman out there, a guy with intelligence and magic powers. Fine. Yeah, at least the starting point, we can at least imagine. I can put him on the board. I can put him on the screen. I can say, look, that's God there. And I put someone maybe that looks like what the masters of the Renaissance painted, uh, one of those guys. I was going to say Dalí, but Leonardo or, any of those. So the turtles, one of those turtles. The issue is that, God we can picture. We cannot picture four-dimensional space-time. And yeah, what the mathematicians have done is put it out of our reach. And say, look, you just can understand it or approach it through math. And even if you approach it through math, all you have is a description. You don't have a mechanism, because the mechanism, they say, well, that's our interpretation, but we don't pay attention to the physical interpretations. All we care about is the description. And that's what they've converted physics into. And that's why all you have today is descriptions. So what is the problem with all this? Well, the problem with all this is that, let's see, Martin, you're saying if you contour the thread as a dude, is he God? Not understanding the question, Martin, but maybe you had too many beers. 6% beers. Anyways, this is the point. The point that I'm trying to make here is that you need to establish the foundations of physics. What are those foundations? The foundations that you need an object. That comes out of what I call the golden principle. You need an object to do physics. You can't do it with concepts. Space-time, particles which are not really particles but are really vibrations or excitations of the field or energy or whatever. Those are concepts. Those don't qualify as physical objects. And all the stuff of the electric universe, none of that qualifies as an object either. Plasma is not an object. Electricity is not an object. Vortex is not an object. Ether is not an object. And neither is, current. Whichever current you want to put in there. All these are concepts. They're dynamic concepts. You can't say plasma does this or plasma does that. Why? And one guy criticized me and says, look, you said that gas is an object. So the question is gas an object? How can gas be an object and plasma not be an object? Okay, so let's understand what the difference is. And I have here a little chart, and we'll put it in the proper context. Okay, look at the chart here. Okay, look on the right side. You have solid, liquid, gas, and plasma. What is plasma? Supposedly a state of matter, the fourth state of matter, as they call it. Okay? And you say, well, isn't that an object? Well, no. The context there on the right-hand side, okay? On the right-hand side, the context there are categories. Solid is not an object. Liquid is not an object. Gas is not an object in this context. Here we're talking about the states of matter. These are different vibrations of matter, different temperatures of matter, different pressures of matter. This has nothing to do with a standalone object. I can't point to a solid. I'm pointing to a cube, an ice cube. That's a solid. But I can't point to a solid because solid is a category in this context. Okay? So if the guy says, look, plasma, how can you say plasma is not an object if it's a state of matter? Well, the guy's shooting his own foot. He doesn't even know it. He's referring to a category of matter, and he thinks it's a standalone object. He's confusing, it's like saying furniture. Is furniture an object? No. Table is an object. Furniture is a category, okay, of things. Clothes. Is clothes an object? No. A coat is an object, a pair of pants or whatever. So when you're talking about categories, in that context, plasma is not an object, not a standalone object. But that's one definition. What's the other definition of plasma? Well, the other definition of plasma, or notion used out there, is that you have to ionize an atom. to get plasma. What does that mean? It means, and we're going to use the standard explanation so we don't get into rope model, okay? According to quantum mechanics, if you're going to follow that, you have to ionize an atom. What does that mean? It means you're going to strip. Strip is a verb, okay? You're going to strip an electron from its atom, and you have ionized the atom, in this case, positively. And you have a negative electron and a positive ion running around. You need to strip the electron from the atom in order to ionize it, and plasma is ionized gas. Ionized, verb or adjective, depending on how it's used. You got to do something to the gas. So how is gas an object? How is plasma not an object? I can take a bundle of gas, air, helium, CO2, any gas. I'll put it in a balloon, okay? Turns out that I don't know which of the gases is inside the balloon. Does the gas inside the balloon have shape? Yes, the answer is yes. Anything made out of atoms has shape. This is not a question, what is the shape of gas? No, that's not the question. It's a yes or no type of question. Does gas have shape? And the answer had better be yes. The air I breathe, it's got shape. I can put it in a balloon and it'll have a spherical shape. Around the earth, it's got a shell shape air, the gas that surrounds our planet. You take the astronaut, he takes the balloon out there in the middle of space, pops the balloon, and this blob comes out. I take a snapshot. Let's say it's color coded. Take a snapshot. That snapshot has shape. That the whatever comes out of the on the photograph has shape. But it's got an irregular shape, Bill, and it changes from second to second. Yeah, I don't care. It's got shape. It's a yes or no type of question. That blob has shape. Now, it turns out that I don't know what gas I put inside the balloon. It could have been air, maybe it was helium. So instead of saying, oh, there's air inside the balloon, or there's helium inside the balloon, I say there's gas inside the balloon. Under that context, gas is a physical object. That gas has shape. It's a yes or no type of question. It's made out of atoms. It has shape. That's different than saying that I have plasma in there. How can you have plasma if plasma requires that each individual atom, we're no longer talking about the entire volume. Now we're saying that each individual atom has to have an electron leave it, ionize it. Something has to happen every single second for me to have plasma. And there's also recombination, by the way, but the point here is plasma is a dynamic concept. You cannot say plasma did this because what you're saying is a jumping kangaroo is jumping. That's what you're saying. You can't have jumping kangaroos jump. They're already jumping. I don't care if they're jumping on a truck that's jumping. It's already in motion. So you cannot continue to use the word plasma as a physical object. And of course, the person who has been with plasma so many years, he's not going to back off. He knows his God is dead right there. And so his whole life depends on that God, and he's just going to hang on to his plasma any way he can. Same with electricity. The electric universe talks about electricity. That's why they're called the electric universe. They talk about these filaments connecting every star, every galaxy. They put pictures, evidence. That's all they can do, put evidence. They never try to reason it out. They just put evidence to try to convince you, to try to recruit you. Electricity is a dynamic concept. There is no standalone physical object called electricity or current. There's something in motion. In motion. No object in the universe is in motion. You have to treat all objects in the universe, for the purposes of physics, you have to treat them as if it were the only object in the universe, no motion. Table, you point, and it's the only object in the universe. That's all you're staring at, table. Dog, Tree, you can put a single tree and you can point to it and say tree. It's not moving, it's not shaking its leaves, nothing. Do that with plasma. Do that with electricity. Point and, what are you going to point to in electricity? It's the only object in the universe. What are you staring at? No, current has to be moving. That's why it's called current. The word current came from the notion of a river because that's the analogy that was used for electricity, that there was a flowing something in there. So electricity is a flowing something, and it's that something which is the object, not the flowing. And the problem is electricity, plasma, they come with motion, they come with flowing, they come with ionization. They don't come alone, just the atom. And people want to dismiss that as a semantic army. Oh, you're just confusing me with all this verbiage. And again, we start physics at language. We need to get the language straight because we are going to provide a physical interpretation. If you're going to provide a physical interpretation, you had better get the language right to begin with. And if you don't know what plasma means, or you're just going to say, well, plasma, you know what I mean, and let's keep going, then you fail to identify the problem. And the problem is language at that point. We can't let you continue until you fix the problem with plasma, until you understand that plasma is not a physical object. You can't use it as a baseball bat. You can't say that plasma this, because plasma is already doing something before you do something with it. Plasma is not a standalone object. You can't point to plasma. You got to watch a movie. And that, of course, that destroys many religions, electric universe specifically, and these people will continue talking about plasma and electricity. Turns out their electricity, to make matters worse, is based on planetary model that Niels Bohr created and Rutherford created at the beginning of the 20th century. What is this planetary model? Well, the electron goes around the proton, or the center of the atom, whatever. Point is, the only question they have to answer is what keeps the electron bound to the proton? That's the only question you got to answer before you can move on. And if you cannot answer what keeps the electron faithful to the nucleus, you don't have a model. We can't even let you begin. We remove the microphone away from you. We can't even tell your theory. You got to fix the proposal first. Your assumption. What does your atom look like before we can begin the presentation? Does your atom look like Bohr's planetary model? Is that what you're going to say that electricity is? Is it the jumping of a little bead from atom to atom? Is that what you think electricity is? So, before you can make all these filaments that bind all these galaxies and stars together, before you can bind anything, you got to show us continuity. And right now, all you have is discreteness. All you can show us that the electron bead, discrete electron bead, jumps from one atom to the next. How does that keep the integrity of a filament? That filament should break apart because you haven't identified the entity that keeps it all together. You haven't identified the glue. That's the problem. So the problem is your atom. And until you fix your atom, you cannot talk about electricity. And the problem with the electric universe is, again, what they do is they use Bohr's model and they just continue to say, well, we can't see it anyways. We don't know what it looks like, but let's continue. This is a conceptual issue. You got to draw it on the board, and what you got to draw is not the real atom. We don't care about the real atom. We want to know your atom, the one you're going to use for your presentation. And before you can move that electron around, you got to tell us how that electron stuck to the proton to begin with. What is it between the electron and the proton? And please don't tell me it's a field, or energy, or mass, or who knows, force. You got to identify the physical object that binds the bead to the proton. And until you do that, you don't have a model. Okay, well, I don't have too much time, but let me just round up the other part. I always get beat up on that one. That's the extinction issue. And the only thing I'll say about extinction, which is what I said at the conference essentially, is that the word you got to focus on is not man. I mean, the theory is about the extinction of man, right? imminent, upcoming extinction of man. And people say, well, Bill, you're crazy. Okay. Aside from that, let's get to it, to the point. The point is that before you can talk about extinction of man, you got to talk about extinction. That's the key term. And people say, well, how can you even think that 8 billion people are going to become extinct, are going to die all of a sudden? And then again, a mass extinction is the geologically swift extinction of millions. That is what a mass extinction is. Swift, geologically swift, right? Death of millions. They die, and don't reproduce for some reason, and that's the end of the line. So yeah, that's the first issue. And the other issue is we got to go back and figure out how extinction happened to those that are certified. There are no dinosaurs around, but their bones are in the layer of rock. There are no synapsids around anymore, but they were in a layer of rock even before the dinosaurs. We can even figure out when they stopped existing. They were no longer there. So before we can reach man, we got to figure out the animals. Right now, we have a lot of irrational theories out there. The one for the dinosaurs, that an asteroid hit the Earth, killed all these animals one way or the other and through indirect effects. And the question is whether that theory is rational. And how did the synapsids of the Permian die? Well, they died, there's really two extinctions. One's in about the middle of the Permian. The Kangurian is known as that age. And those were the Edaphosaurus and the ones with the sailbacks and so on. Those died in the Kangurian. Then the Permian continued with other synapsids, and finally 252 million years ago they disappeared as well. How did they die? Well, the reigning theories are, volcanic eruptions just covered the land with lava. Had to be some kind of big Mother Nature accident. There's another one that says, that you have these plumes come from underneath the water, CO2, methane, filled the land, went through these cycles of climate change, killed all the animals. Not all of them, obviously. And before that, you had the Ordovician, another one I covered. I just went through these kind of quickly. The Ordovician, NASA pushes a lot of these. Why? Because in the case of the Ordovician, it says there was a supernova. And the supernova happened so close to the Earth, it just wiped out the air. For a few seconds or minutes, the air came out during that zap, and then it came back. And in that split second, well, a lot of animals just gasped to death or whatever. No, those are all irrational theories, and they're pushed by NASA because NASA wants you to focus on their projects, which are all extraterrestrial. And so as long as you keep your attention focused on what's happening out there, asteroids, supernovas, or anything like that, then they've got it made. They say, look, send the funds in. We're going to keep we've got all these guards watching every night to make sure that no asteroid hits us. So yeah, climate change more or less along the same lines. And no, the theory is that I'm proposing is that all these animals disappear when their food sources disappear. And the food sources will disappear after millions of years because of two reasons. The overturning of the population pyramid of the plants, and because they lose genetic diversity. And that's a natural process. It will happen no matter what. It has happened. We had the ferns, especially the seed ferns. They died completely, disappeared forever at the end of the Triassic. Maybe a couple continued, but essentially they were gone. We don't have seed ferns today. And we have the cycads. That's what the age of dinosaurs, the Jurassic, and especially Jurassic, is known as the age of cycads. This was an age where cycads covered the land. These are conifers, special types of conifers. And that's what the animals ate. They got used to these plants when the plants disappeared because their population pyramid overturned, because their genetic diversity whittled out after millions of years of inbreeding. Well, after that happened, the animals that forged a relationship, especially those dynasties of animals that forged a relationship, symbiotic relationships with these plants, they would eat the plant. Their coprolites were seeds, and here the plant would grow again. So there was a good relationship between the animals and the plants. But after millions of years, the plants had to go, and the animals that forged a relationship with those plants went with them. That's what happened. And those are predictable processes, those are inevitable processes, and you won't find a single theory anywhere that states that. And so, if that's what caused the extinction of mass extinction of the animals, well, we got our work cut out for us, because it means humans are going to die in the same way. Our plants are going to disappear, which sustains 8 billion people on Earth. And you say, how is that possible? And that's when we walk into economics, because we produce the food that we eat ourselves. It's a bootstrap kind of mechanism. We produce the food thanks to money, and money is this abstraction that we created that we all believe in. And the day we lose faith in the God of money, we stop producing the food that keeps us alive. And that's a long story, and I don't have time for that. But just so you understand the overall theory, I'm going to try to put up the two presentations this week. So keep an eye out for them if you're interested in the subject matter. And hopefully by Wednesday I'll feel a little better and we'll be able to talk better. So we'll see you then. Bye bye.